Okay, this video is on section 2.6, which is titled Families of Functions. And the learning target for this is to analyze transformations of functions. So when you're talking about a family of functions, you're going to always have something you want to start with. And the very beginning of any starting function is going to be called a parent function. And that is the simplest form in a set of functions. So I'm going to be indicating it through all these examples as f of x. Some general examples of what a parent function looks like is f of x equals x is a parent function, x squared, and the square root of x. You'll see as we go through some of the transformations what makes them different parent functions between themselves. But once you take your parent function, you want to make it a little bit different. That means you're going to apply a transformation to it, or you're going to change the parent function. And there's three different types of changes that we're going to go through, and all of them will apply or some of them will apply this letter k, which is a constant, could be any number, 1, 2, 3, 4, 5, 6. It just doesn't have a variable. So the first one is going to be a translation or a shift, and that basically means you're just taking the graph and you're moving it left and right, up and down, but it's not changing any shape. It's not getting shorter, it's not getting flipped or rotated. It's just moving up and down, left and right. So if you want to move a function vertically, that means you take whatever the parent function is and you add or subtract, depending on your direction, k units. So for example, if you want to take your f of x equals x function and move it up 2 units, that means all you have to do is add the 2 at the end. If it was moving it down, it'd be negative, but up is positive. Then if you want to do a horizontal shift, this is where it gets a little bit different. Again, you're going to be adding or subtracting k, but it's going to be inside a set of parentheses, and the direction is going to be different than what you would normally think it. So naturally you would want to think, oh, plus means moving it to the right and minus means moving it to the left. In horizontal, it's actually the opposite. So this function, f of x equals x minus 4 squared, using this parent function x squared, you would think that it's moving to the left 4 since it's a negative. But since it's a horizontal translation, that means it's the opposite. So if you move left, it's positive, and if you move right, it's a negative. So this transformation is being moved to the right 4 units. Then the next one is a reflection, and that's basically flipping the graph. So if you have your function, you're not moving it at all, you're just reflecting it off of one line, or if you put a mirror in between it and flip it, that's, I guess, one way to think of it, like a reflection. The two different types of reflections are across different axes that we're going to be talking about in this class. Across the y-axis means you put a negative on the inside of the parentheses of the parent function, and across the x-axis means you put a negative on the outside. So if you start out with f of x equals x squared, which is a function that looks like this parabola right here, if you put a negative on the outside of the function to make it negative x squared, it's going to flip it across the x-axis or flip it down, reflection. Then the last one is a stretch and a compress. So a vertical stretch is if you're taking your graph and you're making it bigger, but the direction I want you to think of when you think of a stretch is pulling up the y's to be greater. So this graph is getting taller and it's getting a little bit skinnier. And when you apply that transformation to an equation, all that means is that you're multiplying by some number a as long as that's bigger than 1. So if you multiply it by 2, 3, maybe even 3/2 or any fraction or decimal that you can think of, it just has to be bigger than 1 that you're multiplying. Then a compression is the exact same concept of a stretch, but instead you're taking these points and you're compressing them down to be a little bit shorter, and it may get a little bit wider. But the y points are being pushed closer together. Then that means that any number that you multiply by that function for a compression is going to be between 0 and 1. So it has to be a fraction or a decimal, but it must be positive and less than 1. If it's negative, that's where it's going to come in with this reflection, with the negative. But all the stretches and compresses are just positive numbers. So stretch is bringing it taller, compress is bringing it shorter. Reflection across the y-axis means negative on the inside. Reflection across the x-axis means a negative on the outside. Then vertical shift, positive on the outside, negative on the outside, negative on the inside, positive on the inside. And we'll go through a lot of examples, and you'll just get more familiar with it as we're working on. All right, thank you.